Hello, welcome to my channel. So today I'm going to show you some examples where we can apply conservation of linear momentum. Here I have a 2-meter long low resistance dynamic track on a leveled surface, a table. And then I have two equal mass plunger carts from vernier. And what I'm going to do is that I'm going to press this button over here, and then there's a spring, it's spring loaded. So then the two masses will move in opposite directions to conserve linear momentum, because initially, as you can see, the system is at rest. Okay, the system is at rest, and after pressing this button, again the total linear momentum of the system should be conserved, because there are no external forces acting on the system. At least they are minimal, negligible. So let's see what's going to happen. Okay, hopefully you can see the two carts at rest. And now I'm going to press this button, push it down, and then let's see what's going to happen. So you saw what happened. So when I push the button, the two carts, basically like this, the two carts move in opposite direction. So that means, again, the linear momentum of the system is conserved. So that's the first example where we can apply conservation of linear momentum. So this is the second example. This is an example for nearly perfect elastic collision. So I have the same two plunger carts now. What I did was that I fixed magnets to these ends, and on the other cart again I have the same magnets, north and north pole. So the north and the north pole here, they will repel one another. So when I basically move this cart towards the other cart, they are not going to touch one another, but their magnetic fields will interact and there will be a repulsive force. So what's going to happen is that the kinetic energy of this cart will transfer into the magnetic field between these two carts, and then it will be stored as magnetic energy, magnetic potential energy, and that energy will be transferred to this cart as kinetic energy, and that will be moving to the other side. So let's see what's going to happen. Hopefully there will be complete linear momentum transfer from this object to this object. So when this interacts with the magnetic field, there will be no contact. So nearly all the kinetic energy will be transferred to this object, and since it's an elastic, nearly elastic collision, momentum will also transfer, and you will see this object is going to remain at rest and this will move. So let's see. So you saw that. Now this is the third example where I have these fixtures over here. They are gonna connect with these ends. Okay, so this is an example. The example that I'm gonna show you now, it's an example for perfectly inelastic collision. So the two objects will stick together and move. So again, I'm gonna move this to the right, and then it's going to stick to this object, and both will move as one object. So this is an example for perfectly inelastic collisions. So let's take a look at this. So that's an example for perfectly inelastic collisions. So these are three examples where we can use conservation of linear momentum to understand what's happening here. Thank you for watching this video.